We usually think of AI as this single, super powerful brain. But what happens when a task is just too big, too complex, or way too important for just one model to handle? Well, it turns out the solution is to teach AIs how to team up. So today we're going to dive into three really cool design patterns that do exactly that.
So that's the big question, right? Whether it's whipping up content on the fly or making a huge business decision, a single AI can often just hit a wall. It might be way too slow, it could forget key details halfway through, or, let's be honest, you just might not be able to trust what it spits out.
And this is where it gets really interesting. The answer isn't just to build one single, even bigger AI. Nope. It's about creating smarter systems of AIs, teams that can actually collaborate. These are called agentic design patterns, and they're basically blueprints for AI teamwork. We're moving from a solo artist to a full-blown orchestra.
All right, let's jump right into our first problem, speed. We all know generative AI can create some absolutely amazing stuff, but man, it can also be painfully slow. And that's a huge issue, especially when you've got a user just sitting there waiting for something to load. This slide just lays it out perfectly. The old way, over on the left, is basically a traffic jam. One AI trying to muscle through a huge task all by itself. But check out the after on the right. It's like opening up a bunch of new highway lanes. The task gets chopped up into smaller pieces, and a whole team of AIs gets to work on them all at once. The result? A massive speed boost. So the first pattern that makes this happen is called agent-led parallelization. And the star of this show is the orchestrator agent. Think of it like a head chef in a super busy kitchen. The chef doesn't cook the entire 5-course meal alone, right? No way. They break the order down, grilling, chopping, plating, and hand those jobs off to different cooks to do all at the same time. So how does this actually play out? Well, it's a pretty logical 4-step dance. First, the orchestrator agent decomposes the big request into bite-sized jobs. Second, it distributes those jobs out to a whole fleet of AIs that are ready to go. Third, and this is the magic part, those AIs execute their tasks all at the same time. And finally, the orchestrator gathers up all the finished pieces and synthesizes them into one final, complete result. But of course, there's always a catch, right? It's not a silver bullet for everything. For one, you're going to need more infrastructure to run all those AIs, and that costs money. Also, for really small tasks, all that extra management can actually make things slower. And this last one, this is the real kicker. The subtasks have to be totally independent. If one task needs another one to finish first, the whole system grinds to a halt and you lose all that speed you were hoping for.
Okay, so that's speed. Let's move on to problem number 2. And this one isn't about speed, it's about memory. See, large language models are incredible, but they have, well, a pretty bad memory, a surprisingly short attention span. And this gets to the heart of the issue. It's something called the context window. Just think of it like the AI's short-term memory. It can only hold on to a certain amount of info at any given time. So if you're trying to write a long report, by the time you give your third or fourth instruction, it might have completely forgotten what you said in the first one. And that makes creating anything complex a total nightmare. So how do you get around that? Well, with a pattern called hierarchical generation. In this setup, we introduce a content master agent. This agent is like the project manager or maybe the editor-in-chief of a magazine. It holds the big picture vision for the whole project, and then it delegates specific parts, like chapters or sections, to a team of specialized sub-agents. And here's what that team structure looks like. You've got the content master, who's the strategist. It breaks down the goal, manages the whole workflow. And then you have the content sub-agents, and these are the specialists. You could have one agent that's a researcher, another that's an analyst, and a third that's the writer. They each do their part, then hand it back to the master, who puts it all together. But as you can probably guess, a system like this has a lot of moving parts. It's way more complex. And if even one of those sub-agents is poorly designed, it can bring the whole project to a screeching halt. The biggest risk here, though, is that you end up with a final document that just feels disjointed, incoherent. Everything hinges on that content master doing a perfect job stitching it all together at the end. All right, on to our third and final pattern. And this one tackles what might be the most important problem of all, trust. I mean, when the stakes are really high, how can we actually be confident in an AI's decision? Seriously, think about it. Imagine you're about to make a huge multi-million-dollar call, like where to build a new factory. An AI gives you an answer.
But what if it's wrong? What if there was some hidden bias in its training data? Are you really going to bet the farm on what a single AI tells you? That's a massive gamble.
And that's where our next pattern comes in, the voting ensemble. The idea here is so simple, but it's incredibly powerful. Don't just ask one AI, ask a whole panel of them. You have an aggregator agent that poses the exact same question to several different AI models. Each model gives its prediction, which counts as a vote. Then the aggregator just tallies the votes to see what the majority thinks. It's like putting together a jury of AI experts. This little chart makes it super clear. Let's go back to that idea of where to open a new store. We ask 3 different models. Model A says downtown. Model B says downtown too, but Model C says suburb. The aggregator agent looks at the votes, sees a clear 2-to-1 majority, and makes downtown the final and hopefully more reliable recommendation. Okay, but this pattern has a really serious dark side. It can create a dangerous false sense of security. I mean, what if all of your models were trained on similar data and share the same hidden bias? They might all confidently agree on the wrong answer. It also costs more. And, this is crucial, it can turn the final decision into a total black box. If the aggregator just says the answer is downtown, you have no idea why. You can't trace the logic. And for high-stakes decisions, that lack of transparency is a huge problem for accountability. Okay, so let's pull all this together. We've seen how teaming AIs up can help solve huge problems with speed, memory, and trust. Let's do a quick recap of the 3 powerful patterns we've just walked through. This table lays it all out for us, nice and simple. If you've got a speed problem, use parallelization with an orchestrator agent. If you're hitting that memory wall, you build a hierarchy with a content master. And if you need to build trust in a decision, you create a voting ensemble with an aggregator. It's all about picking the right team structure for the job. And all of this, it really leads us to one big final question. If AIs can collaborate this effectively with each other, what does that mean for how they're going to collaborate with us? Because as these systems become less like single tools and more like entire expert teams, our whole relationship with AI is about to fundamentally change. And figuring that out, well, that's the next great frontier for all of us. Thanks for joining me on this one.